In this lesson, we shall focus on integration by parts, a topic in mathematics, and we want to prove that this integral here equals the result on the right-hand side. And so to actually, proceed to prove these results, we actually state what we know by integration by parts. What do we know by integration by parts? Right, now integration by parts has a specific formula, and the formula is clear that if you have the integral from a to b of f at x times g primed at x dx, this result is exactly the same as f at x g at x from a to b minus the integral from a to b f primed times g at x dx. So this is exactly the result. It's exactly the result or the formula that we call integration by parts. And in view of this particular question that we have here, we need to obviously take note that then if we have the integral from 1 to 2 of x times e to the power 2x dx, what we do then, we let the following here. We let f at x be x. And now then you're going to have g primed here, because next to the f is g primed at x. So g primed at x is going to be the e to the power 2x. And therefore, what this means that is that f primed at x, if f at x is x, then f primed is minus 1. And if g primed at x is e to the power x, it means that g at x, right? It means that g at x is exactly 1/2 e to the power 2x, exactly this way. And as a consequence, then we actually obviously have the tools we need so that we can actually most certainly say, thus, whenever we have the integral from 1 to 2 of x e to the power x dx, it is f times g, which is this one, x times 1/2 e to the power 2x. You can put this one in parentheses this way. The integration is from 1 to 2 minus the integral from 1 to 2 f primed is 1, and then g at x is exactly 1/2 e to the power 2x dx. Right, so we have exactly this result here. And upon careful inspection, then it is very clear that whenever we have the integral from 1 to 2, which is of this here, x e to the power 2x dx, it is actually exactly what? It's exactly x 1/2 e to the power 2x. It's x 1/2 e to the power 2x from 1 to 2 minus the integral from 1 to 2 of 1 times 1/2 e to the power 2x dx. Right, and so we perform substitution here at this point. And if you substitute the 2, for example, it's going to be 2 1/2 e to the power 2 by 2 minus 1 times 1/2 e to the power 2 by 1. And then here we need to integrate this, and the integral of this is going to be exactly 1/2, but another 1/2 is going to be 1/4 e to the power 2x. And we integrate from 1 to 2. At this point, it is clear that this one is exactly e to the power 4. Right, it's exactly e to the power 4 minus 1/2 e squared minus, right, you plug in the 2, which gives us exactly a quarter e to the fourth power minus, so it's going to become a plus 1/4 e to the power 2. Right, we add like terms like if you add this and that, e to the fourth power minus a quarter of that is going to be 3/4 e to the fourth power. This with that. So now 1/2 is like minus 1/2 is minus 2/4, giving us exactly minus 1/4 e squared. Okay, minus 1/4 e squared. And so now at this point, we can perform algebraic factorization. We can take out 1/4, and we also take out e squared from there. And what then we're able to get is the 3e squared minus 1, which is exactly the result that appears up there. And so we can most certainly be rest assured that we can say henceforth the integral from 1 to 2x e to the power 2x dx is 1/4, and then we have 3e squared minus 1. Right, and so this is the answer we have got here. This is the result we have got here by integration by parts. And so ultimately, we've been able to prove the desired result by using integration by parts. And we remember very well that we started over exactly at this point, where we actually started by looking at the formula for integration by parts. In other words, whenever you need to integrate and you are actually facing the integral from a to b of f at x times g prime at x dx, then this is actually exactly equal to f at x times g at x integrated from a to b minus the integral from a to b of f prime times g at x dx. And therefore, we went on to do the rest of this, and we got the answer. Right, and so we actually made these choices, and these choices were obviously sort of justified by a couple of things. Choosing f at x to be, for example, x was relevant because we saw that the derivative became just a constant, right? Than having to choose f at x to be anything else like the exponential, whose derivatives do not really simplify to a constant as such in a way that allows the complexity of the derivative to sort of reduce. And so we then have been able to obviously state the integration by parts formula there. We performed a substitution into the integration by parts formula. And then we went to obviously, perform the simplification until we got to the result. Right. And so we must thank you so much for joining us. It was awesome looking at the integration by parts literal example. Until next time, take care and goodbye to you.